Started. My name is Tao Chen, and I'm from Microsoft Research. Today, I'd like to share with you our research on a framework for robust discovery of entity synonyms. So this is a joint work with my colleagues, Kaushik, Surajit, and Dong. So nowadays, as probably many of you guys are doing, we're actually increasingly searching for entities. So we go to e-tailers such as Walmart to search for or buy products. And we go to yellow page, sort of like websites, information providers to look for local businesses. We go to, let's say, online music stores such as iTunes Store or Zune Marketplace to look for songs, artists, or albums. So in all these cases, people are looking for these specific entities, be it products, be it local business, and so on. So we think there's actually a mismatch in a lot of these search scenarios. So if you look at a lot of these entity search kind of scenarios, they are really backed by a back-end entity database, right? So Walmart has a back-end database of its products. So you typically will be able to find the product that you're looking for if your query matches exactly with the product name in their database. However, as probably many of you know, that people, they use very different ways to actually refer to the very same entity, right? They don't always use this exact entity name to search for it. So let me give you a few types of these different ways people typically use to refer to entities. So some people would prefer to use acronyms, right? So for instance, Washington State Department of Transportation, for the sake of easiness, people typically just refer to it as WA dot, right? Lord of the Rings is known as LOTR in short. Right? There are another kind of more interesting kind of way people refer where they use totally different words. Right? So for instance, a popular camera called Canon 400D, it's also actually known as Canon Rebel XTI. Right? UW football team is also known as Huskies football. So these are really totally different words, but they refer to the same entity. And there are other types of ways people refer to the same entity in different ways. Sometimes it's common misspellings. Sometimes it's subsets or supersets of tokens. Sometimes it's slight modifications or normalizations of the name of entities. So in these cases, if you happen to use these different ways rather than the way entity appear in the database or entity database, then typically your query will fail to find the right result or the desired result that you're looking for. And in these cases, really, we're getting bad user experience, which means we're losing website conversions as well as sales. So this is what we call this is what basically the kind of problem we want to address. So we want to basically enrich these entities with these very different ways or alternative ways people refer to that entity, right? So we refer to these alternative ways people refer to the same entity as entity synonyms. So if we can mine out these synonyms for these entities, then the enterprise, let's say Walmart or Yellow Page, they can actually index these entity synonym information along with other information about their synonyms in their index, and this will really lead to much better user search experience. So here, let me give you more examples of what we mean by entity synonyms. So for instance, for products such as Microsoft Excel, it's also known as MS Excel or Excel spreadsheet or simply Office Excel. Right? I give you this Canon 400D example just now. It's known as Canon Rebel XTI, but also it's actually also known as Canon, I think it's also known as Canon Digital KISS, something like that. For local entities such as University of Washington, it's known as UW simply, right? So as you can see, a lot of these synonyms, if you rely on simple string added distance or kind of string similarity-based measures, a lot of these are very difficult to find, or some of them are even, I would say, even impossible to find because they share very little in common in terms of string similarity. So there has been a few existing approaches toward finding these synonyms. So one approach is this so-called document similarity. The idea is that if an entity string E and the synonym candidate string S, if they happen to co-occur in a lot of web documents, then this is a good indication saying that they are likely going to be synonyms of each other. So this is one approach. So recently, there's another approach to actually try to look at query click log and try to mine out entity synonyms. So the high-level idea is the following. Let's say you are given the entities, let's say Microsoft Excel. And then you look for the query Microsoft Excel. Now, once you have the query click log, you can look at what are the URLs or what are the web pages people click on when they issue this query Microsoft Excel. So here you will get a set of click URLs. Now, once you get to these URLs, these URLs will lead you to a lot of other queries which also click on these URLs. So these are actually different ways people try to access these URLs. Or in other words, these are actually different ways people have used in the past to access information about, about that entity. So this very rich set of queries provide us what we call provides what we call this set of candidate synonyms. And then once you have these candidates, you can really look at these click information to do some mining to mine out true synonyms out of these candidates. Because as you can see, a lot of these candidate synonyms, they are not true synonyms. So the main idea of using this click similarity is basically if you find out that a candidate synonym shares a large number of co-clicked URLs with the entity, then that's also a good indication saying that they are likely going to be synonyms of each other. So there are actually two main limitations of these current approaches. Now the first one, which is specifically for the click similarity, is that actually click log, especially when you go down to the tail, you will find out that actually the click log is quite sparse. For niche entities or for synonyms which are not that popular, actually the click information is not that abundant, right? So here I give you one example. Still, let's say the entity is still Microsoft Excel, and here you have three candidates, Microsoft Spreadsheet, MS Excel, and MS Spreadsheet. And here you have two documents. So all these three candidates are actually pretty good. They're all, I would say, true synonyms of the entity. However, if you look at the clicks, the first two are sort of okay because they all click on these two documents. But the third one, because of the sparsity in the query log, it only has clicked on document D2. Now, let's say if you apply a very simple threshold saying that a candidate has to click on at least two common URLs, then this MS spreadsheet, which is a very nice synonym to have, actually would be missed, right? So this is the kind of issue we face with click log sparsity, and this really leads to poor recall. The other problem is that sometimes a lot of the candidates, they are very strongly related with the entity. However, they are not exactly synonyms. So let me give you another example. Let's say still Microsoft Excel, and then a candidate, let's say MS Excel tutorial. So in this case, they are very highly related to each other, but they are not synonyms of each other. And here, the problem we see is that these are actually entities from two different classes, right? So the first one is a software, whereas the second one is really about a tutorial. So how can we distinguish entities or candidates of different classes in order to make sure that we get high accuracy? So now let me just briefly state the problem that we're trying to address, which is fairly straightforward. The problem is basically you're given an entity, which is represented as a string, for instance, Microsoft Excel, and then you're given a set of candidates. So you can get these candidates through the click path that I just described. And basically the job is to identify a subset of these candidates such that these are true synonyms, right? So we think there are three very important properties which needs to hold in order to make sure that the synonyms output will be of high quality. So the first one is what we call this reflexivity. This is kind of, if you think about this kind of trivial, it basically says a string is always a synonym of itself. But what this indicates is that actually, this is actually an assumption in this work, which is saying that the entities or the candidate synonyms, they have to be sort of unambiguous. Because if something is ambiguous, then it would only be synonym to itself under some specific context, right? So the second one, which we call is symmetry, is basically if A is a synonym of B, but then B is also a synonym of A. And later on, you will also find this actually is very important property to observe, because you really want to make sure that you do these checks both ways to make sure that they are synonyms rather than let's say hypernyms or hyponyms. Finally, they have to satisfy this similarity property, which means that two things. In order for them to be synonyms of each other, they have to be not only very strongly related, but they also should belong to the same concept class. So basically in this work, we want to address these limitations and try to meet these requirements or these properties. So now let me go into the technical details on how we actually try to address these issues. So let's again look at the same example of this query sparsity, click sparsity. So if you look at this Microsoft Excel, you look at these three candidates. Now what's interesting is that if you look at document D1, it's being clicked by the first two candidates, right? If you look at all these four tokens, these are Microsoft Spreadsheet, MS, Excel, right? So these four tokens actually is a superset of the tokens in the third candidate, MS Spreadsheet, right? So the fact that D1 is clicked by these two queries with these tokens, and these tokens are actually highly relevant with the other candidate, is actually telling us something. So here, what we propose is that instead of just relying on the clicks, we can actually go one step beyond. In a sense, we can construct what we call a pseudo document for each document. Now, what we mean by pseudo document is simply you put together the tokens in the queries clicked on that document. So in this simple example, the pseudo document for D1 will consist of four tokens, basically Microsoft Spreadsheet, MS, Excel, these four. Now, once you have these pseudo documents, then you have a way to establish these sort of pseudo links between the pseudo document and other candidates. So in this case, because we see that MS Spreadsheet is actually a subset or it's contained in this pseudo document, we can actually establish this link. So this helps us to better capture these more tailed synonyms. So as I said, we can construct the pseudo document for each document using the tokens of queries clicked on it. Actually, these are very concise and accurate representations of the document. And this really addresses sparsity issue. Basically, this can capture candidates with few or very limited clicks. Now, what's more important is that we need to actually do this checking both ways. So what I mean is that similarly, we can actually do this on the other side. We can actually derive a set of pseudo document for each candidate. And then in the other direction, we can check the pseudo document similarity between entity string and these pseudo documents. So this two-way checking is actually very important. So let me give you an example. Let's say Microsoft Office with respect to Microsoft Excel. Actually, from Microsoft Office to Microsoft Excel, the similarity is actually pretty high. However, the other way around, that's not the case. That's because Microsoft Office is a much broader concept related with a lot of other entities. So it's not just related with Microsoft Excel. So this is actually a hypernym and shouldn't really be considered as a synonym. So it's really by doing this kind of two-way checking that we can make sure we filter out many hypernyms or hyponyms. So problem is not yet solved. We find as I'm motivated, we still find problems such as Microsoft Excel and MS Excel because they are strongly related, but they are not of the same concept class. We think a synonym should be not only related, but also of the same type. So towards this, we use what we call context similarity to make sure that candidate and entity, they are of the same type. So where to find context? Again, we rely on query log. So basically, if you look at query, you find that people use similar words or similar context when they are querying for entities of the same type. For software, people use help, download, and so on, right? So let's run through an example. Let's say we have entity Microsoft Excel and these two candidates. Now you can look into the queries where they appear as part of the query, and you can look at these additional words like download help. And these can be regarded as the contexts of these entities or candidates. Once you have these contexts, then you can basically compare the entity with respect to these candidates using these contexts, right? So in this example, the first two, they have a lot of commonality shared between their contexts, whereas the third one, which is not of the type of software, its context is very different. So by doing this, we are able to, let's say, filter out candidates such as MS Excel tutorial and be able to find true synonyms. So it's really by doing these two type of checks, we make sure that we ensure the similarity property of synonym and output highly accurate synonyms. So typically, we have to actually do this for a lot of entities. So for instance, Bing Shopping has over 15 million products in its catalog. And the query log is also immersed. There are easily billions of queries. So how can we compute all these measures or check the synonym relationship very efficiently? So especially in the case of checking pseudo document, we see a bottleneck. That's because for a given entity, typically it has clicked on many documents, easily in the thousands, right? And then if you look at the candidates, typically there are also thousands of, if not more, candidates. So if you want to check these relationship between these pairs, it's going to be very expensive. So what we see the opportunity is that we can actually build what we call a pseudo document inverted index, which has the inversion from token to the pseudo document. And with this, you don't need to actually check these pairwise. You can leverage this index to speed up. What's more is that you can also build similarly index on the other side, basically from token to candidate. And you can leverage these two types of indexes such that you don't need to actually touch the candidates or the pseudo documents. You can do all the operation based on the indexes, which is very efficient. So due to time, I don't have time to go into depth about this. So we have experiments on two real data sets. One is about softwares, one is about local business names. So here, first, we want to show that by comparing pseudo document similarity to ClickSim and document similarity, we are actually improving quite significantly in terms of precision and recall. And similarly, we are observing a similar pattern for the local data set, right? So another experiment we did is how basically to see what's the benefit that's brought in by adding this query context similarity. And again, we are seeing boost by adding this important feature. So finally, we have some experiment results on efficiency. As we can see, we have the naive, which is this pairwise comparison, and we have the first one, which is just having the pseudo document inverted index. And finally, we have the dual index, basically leveraging the index on both sides. And we can really see this really significantly speeds up the computation. So we actually were able to actually ship this as part of Bing Shopping as well as Bing Video, and they did some pilot study to see this the effect in production. And they're getting actually, because that's a highly optimized framework, we're seeing 0.1 NDCG gain in Bing Shopping and 0.2 NDCG gain in Bing Video. But what's more interesting is that if you look at these difficult queries where the previous NDCG is almost 0, we're actually bringing almost 1 point improvement in NDCG. That's in production, right? So to summarize, here we have presented a framework with desired properties for finding synonyms of entities. And we defined two interesting similarity measures. We designed efficient scalable algorithms to compute them efficiently. And finally, we have experiments on real data sets, and we also have shown some real product impact. So I think that's the end of the talk. Thanks.
It seems that you consider the context word only after the entity. Do you consider the context word before the entity?
So that's just an example I quoted in the slides. In fact, we look at both the left-hand side and right-hand side of this.
Okay, and I have another simple question. In your slides, page number 7 or 8, there is a concept class. What's the definition of concept class?
So this is what we try to capture by using these contexts, right? We believe that, so concept class is, let's say, software is a concept class, tutorial is a concept class, camera is a concept class. And we believe that